An organic compound contains 60% carbon, 13.3% hydrogen, 26.7% oxygen. Calculate the empirical formula. Given the atomic mass of carbon to be 12, hydrogen 1, and oxygen 16. Solution. If you are yet to subscribe, you are definitely missing out on videos like this. So as not to miss out on more videos like this, kindly subscribe and click on the notification bell as well so as to be notified as soon as more videos are being released. There is a link as well in the description box to the Telegram channel. You can join the channel via the link for more communications. Now going back to the question, you are being asked to calculate the empirical formula of the organic compound that contains carbon, hydrogen, and oxygen. We are given the percentage composition of each of the elements as well as the atomic mass of each of them. I would like you to note that empirical formula is a formula of a compound that shows the least possible number of atoms present in the compound. And to get the number of atoms present, we need to determine the number of moles of each of the elements present in the compound. And by determining the number of moles, we'll be using the formula that says mass divided by molar mass. But in this case, we'll be using the atomic mass since we'll be working with each of the elements individually. To save time, we'll be working out the number of moles of each of them simultaneously. Instead, we're going by the long way of calculating that of carbon, hydrogen, and oxygen before merging it together. So just do everything in its tabular form and solve simultaneously. I would also like to chip this in. The percentage composition can also be likened to the mass of the element since we are dealing with 100%. Taking the mass of the compound to be virtually 100 grams, definitely carbon will be 60 grams, hydrogen 13.3 grams, and oxygen 26.7 grams. I'm saying this so as not to cause confusion when we proceed using our formula for moles, which is mass over relative atomic mass. So let's continue. In a tabular form, I have carbon, I have hydrogen, and I have oxygen, the elements that made up the compound. So on this side, I'll say percentage composition by mass. For carbon, 60. For hydrogen, we have 13.3. And for oxygen, is given to be 26.7. The next thing is to state the atomic mass of each of them. So on this side, I have atomic mass. From the question, carbon is 12, hydrogen is given to be 1, and oxygen 16. Next thing is to determine the amount of each of them, which can also be referred to as moles. So here I will say mole. Or better put, say mole ratio. I have 60 divided by 12. Here I have 13.3 divided by 1, 26.7 divided by 16. So dividing this, for carbon we have 5, for hydrogen 13.3, and for oxygen we have 1.7. This could have been the end in determining the empirical formula, but our formula must not contain a decimal value. It should be in whole numbers. That is, I mean the subscript of the elements in the formula. So now, since the subscript should be in whole numbers, then we have to find the simplest ratio in which each of them can combine, and to get the simplest ratio, we'll be dividing by the smallest. That is the smallest value amongst the elements carbon, hydrogen, and oxygen. Looking at the values we have above here, the list here is 1.7, hence we'll be dividing through by 1.7. So on this side, I'll come here to say divide by the smallest. The smallest is 1.7. So 5 divided by 1.7, 13.3 divided by 1.7, 1.7 divided by 1.7. So after dividing this, 5 divided by 1.7 gives 2.9. Here we have 7.8, and here for oxygen we have 1.0. And we've gotten the least values with which each of them can combine, yet we are still having them in decimal form. So what we'll be doing this time around is to round it up, because if we should go by dividing by the smallest again, the least is 1.0, we will continue to have the same values. So what we'll do at this junction is to round it up to the nearest whole number. So for carbon we'll be having 3, for hydrogen rounding this up we'll have 8, and for oxygen we have 1. So they are combining in the ratio of 3, 8 and 1. Hence the empirical formula will be equal to C3. This 3 is gotten from the number of moles we got here, the least values here. So that will be the subscript of each of the elements. So here now we have C3, for hydrogen 8, we have H8, and for oxygen is 1, we have O. 1, we are supposed to write 1, but the writing 1 will be insignificant, so we neglect that. And this makes the final answer to be C3H8O. That will be all. Do not forget to subscribe and click on the notification bell so as to be notified as soon as new videos are being posted here. And leave your comments in the comment section below. Like and share the video. As well, join the Telegram channel via the link in the description box for better communications. Thank you.